Hey there! We are starting a very short unit on sequences and series. So today and tomorrow we'll be doing an introduction. Knowing vocabulary, knowing how to write things and interpret what you're writing, and knowing formulas will all be really important. Now, sequences are just a list of items that are separated by commas. The items in a math class would typically be numbers, and those numbers would typically follow a mathematical pattern. We can have random sequences of numbers, but that wouldn't be something we'd need to study in an Algebra 2 class. Notice in green it says that sequences are functions that only accept counting numbers as input values. So let's explore what I mean by that for just a minute. So if you look at a function, I'll do a real simple one, like f of x equals x plus 1. Now functions accept any real number input. So I could say, well, let's do something nice like f of 1 and get 2. Or I could say, let's do something like f of 0 and get 0 plus 1 is 1. Or I could put in negative numbers. F of negative 1 is negative 1 plus 1 is 0. But I can also plug in fractions. I would get 1/2 plus 1 is 1/2. I could also plug in really weird numbers, like f of negative pi, and that's going to be negative pi plus 1. So functions will accept counting numbers and 0 and negative numbers and fractions and radicals and decimals and irrational numbers and rational numbers. The other thing we know about this is this function represents a line. The line has a y-intercept of 0, 1 and a slope of 1, so I'm going to go up 1 over 1. And every possible point I could come up with, like this point, which is I plugged in negative pi and got negative pi plus 1. Every possible weird point is somewhere on that line. Now, the related sequence would be a sub n equals n plus 1. So when I write it like this, the only input values are counting numbers. So if I said let's do a sub 1, that means do 1 plus 1, and that's 2. If I say let's do a sub 2, you're plugging 2 in for n, and 2 plus 1 is 3. If I said let's do a sub 3, it'd be 3 plus 1 is 4. So now, if I were to plot the points that I've just generated, I'm saying when I plugged in 1, I got 2. When I plugged in 2, I got 3. When I plugged in 3, I got 4. So in a sequence, you're going to get a bunch of dots, but you're not going to connect the dots and get a full-on line. Now, I'm going to get more dots because, for instance, when I said sequences are lists, I know my list is that the first term in the sequence is 2, the third term in the sequence is 4, the third term in the sequence is 4, the fourth term in the sequence then will be 5, like I can see what the pattern is. So I would get another dot by going up 1 over 1, up 1 over 1, up 1 over 1, and they're going to go forever from there. Now let me mention something about notation. A sub 1 equals 2 means the first term in the sequence or in the list is 2. A sub 2 equals 3 means the second term in the sequence or in our list is 3. All right? And so the last line is telling me the third term is 4. I think I boogered that up when I said it earlier and skipped the second term is 3. So that's the way you read sequence notation. Now, let's look at series. Instead of series just being a list separated by commas, series are summing the terms of a sequence. So you don't put commas between, you put plus signs between. Now on a sequence, all you can do is list it. On a series, though, you evaluate. So you make your list separated by plus signs, you add all the terms, and you find the sum. That's what it means to evaluate a series.